All right, this is really getting into some algebra here. So the key to this, I think that was that this learner was really struggling with is that it says not to graph it. So if we could graph this, then finding the zeros would be really straightforward. But without graphing it, then we have more of a challenge, right? So couple of things that we would do here. So the vertex and axis of symmetry, this is in vertex form, which is fantastic. You know, this is f of x means y. So y is equal to this. So the vertex is the opposite of the parentheses. So -2 instead of +2. And then the number at the end is a -1. So the vertex is -2, -1. The axis of symmetry is always x equals. So whatever the x was in the vertex, it was -2. That's the axis of symmetry. If we were to graph this, that would be the higher low point at -2, -1, and then it would be symmetric on either side of that point. Okay. So the zeros of this parabola, to do that, I mean, there's more than one way to do it, but without graphing it, I would recommend taking this. And let me just write it here, x plus 2 squared minus 1. And let's put it into standard form so that we can do quadratic formula. So to do that, we want to square this. So that's a whole process in itself as well. X plus 2 squared means x plus 2 times x plus 2. And so we'll need to distribute, you know, x times x is x squared, x times 2 is 2x, and then we'll distribute the 2. 2x is 2x, 2 times 2 is 4. Combine like terms, we have x squared plus 4x plus 4. And so this is x squared plus 4x plus 4, and then we have the -1 still. So to clean that up, we can combine like terms. We have x squared and 4x, but then we have 4 minus 1, which is 3. Okay, so let's do the quadratic formula for this, because the quadratic formula always gives you solutions for x. It gives you those x values at as long as it's set equal to 0. And if it is set to y, then that is set equal to 0. So again, I'm covering a lot of things that, you know, maybe the prerequisites here are the things that you already needed to know. I hope this is not overwhelming you. This is multiplying polynomials. If you're looking for help with that, sometimes it's called FOIL or double distribution. And, you know, this is vertex form of a quadratic. We're converting the vertex to standard form, and now we're about to use quadratic formula. So this is using a lot of information here. So I'm going to erase this because I need this workspace for quadratic formula. So I know that I need my A, B, and C to do the quadratic formula. And so that's 1 is A, or A is 1, B is 4, and C is 3. It's nice that it's in order, A, B, C, right? And the quadratic formula says -b. So -4 plus or minus square root of b squared. So 4 squared minus 4 times A is 1, times C is 3. And all of that is over 2A, and A is 1. Okay, let's start to clean this up. 4 squared, that's 16. 4 times 1 times 3 is 12. 16 minus 12 is 4. So this is all actually the square root of 4. Well, that's nice because the square root of 4 is 2. So let's see. We have -4 plus or minus 2, because all of that is just 2 over 2 times 1 is 2. Okay, we're almost there, believe it or not. All right, so our two problems are -4 plus 2 over 2, and then -4 minus 2 over 2, because it's plus or minus. So -4 plus 2, that's -2, divided by 2 is -1. So one of my answers is -1. So one of my zeros is -1. The other one is -4 minus 2 is -6 divided by 2. That's -3. So -3. Don't put parentheses, put brackets around it because it's not a coordinate pair. Those are both x values. Those are the zeros. It means the zero means where are the places on the graph where the y values are at 0. So we had to take the long way around it simply because the directions say that we are supposed to prove it that way. If we're proving it with that, then we're, without graphing, then this would be the process that we would have to do. Yikes. Not simple, but each part of it, is its own process. So it's understanding all the little pieces that make up the bigger picture. All right. I hope that's helpful. See you next time.